Well, welcome back to our class on system engineering. We're continuing our process of going through some introductory material on system engineering from our main textbook. That is the construct in which we're getting this perspective on system engineering. We've gone through an introduction to system engineering. We talked about the process of system engineering. Now we're going to be talking about the modeling. And so this is where Booty talks about Sysml. He doesn't talk about it extensively. He also spends more time talking about IDEF0. And as I stated before, I'm not going to be focusing that much on that. So this will end up being a short lecture because the detailed discussion that he develops on IDEF0, I'm going to just defer. You'll have the charts. You can look that over. And I also have some separate lectures that talk in more detail about Sysml. So in this chapter, it provides an overview of modeling and the types of modeling needed in system engineering. Modeling methods associated with Sysml are then introduced. And while IDEF0 is not part of Sysml, this topic has been kept in this chapter as a part of the modeling concepts. And so we're not going to explore that in detail, but it's available for you if you would like. So here is just an example of a simplified Sysml method. And so this is consistent with the system engineering process described earlier and the practical guide of Sysml. The method is used to produce the modeling artifacts that constitute the system model. And so why I'm trying to show this here is this is trying to give us a perspective on the system specification and design. And so in Sysml, we're trying to show the actual process of doing designing, and this is captured in an activity diagram here. So you organize, analyze, specify the requirements, synthesize the alternative solutions. And in parallel, you're doing you maintain the requirement traceability and perform the analysis. So this is just one way, one of many different perspectives of how you can be thinking about what you're doing. You need all of the different Sysml diagrams to be giving a complete design. And so, but that's maybe gives a perspective. Another important thing, and it's nice to have a simple diagram to first introduce us, is show the relatedness of different diagrams to other diagrams here. And so there's four main areas in Sysml: the structure, the behavior, the requirements, and the parametrics. And so what these lines, these arrows are showing is the relatedness between parts of a model to another part of the model. And so this is why I like to be thinking of when you create a Sysml model, you're creating a database, and then you have different views that show some of the relationships that are there that it can be started to be played out. And so in a block definition diagram, or here we're showing an internal block diagram, shows where an element there is started to be played out into the parametrics. And so you have the physical constraints of how things operate. And so you see relatedness between that. You have the requirements that a parameter has to be, it's designed to reflect what is a requirement that's set into the different layers of requirements that are put into a design for an activity. And so you have a block here. And so you start with one block, and that shares information with another block. And so you see the relationship between the different blocks in activity diagram with what's defined in a block definition diagram or an internal block definition diagram. So that just gives you an idea, one of many, of showing these relationships that are important when we're thinking about Sysml. So this is just another example showing maybe a few still notional blocks of these four different main groups. And then we have, like what we just talked about in the previous diagram, just showing you the relatedness between those, as I've already tried to allude to. So you could stop the video and just look at this for a few minutes if you find this is a benefit. But this is, I think, is is an important point for you to be thinking about. Okay, there are some examples here of the different types of Sysml diagrams. And so here is a package diagram. But let's first talk about the more high level of what we're trying to do with modeling. So models are not a complete representation of reality, but you can model as much detail as necessary to help you in the design, modeling, verification, and deployment process. But it answers questions, so you need to define what those questions are. And so the types of questions can be definitional, descriptive, or predictive, and can be normative. And so define what questions and write them down what you want a model to be doing. So here's another diagram I thought was useful from the Practical Guide to Sysml is a taxonomy of models. So you can have a symbolic model, and below that you can have the descriptive model or an analytical model. And in terms of descriptive model, you can have a geometric or a logical model, different types of things. This is not exhaustive, but it shows you just some of the symbolic model elements that can be laid out. So in terms of model categories, you can have physical, quantitative, qualitative, and mental. And so those are the categories. And in terms of subcategories, for a physical, you can have a full scale, a subscale, or a breadboard. And so where are you in the development process? And then you can be, here we get into some of the questions. So for a physical model, how much, how often, how good do they match? And so you can be seeing those things that you could be trying to play out with a physical type of model development. For quantitative, you can be looking at analytic simulation or judgmental type of subcategories. Some of the same question, how much, how often, how good. For qualitative, you can be thinking about symbolic, textual, or graphical type of subcategories and what needs to be done, how well does it need to be done, and by what or by whom. And finally, the mental model, and you're trying to provide an explanation, and this can be including all of these different types of questions, still at a high level, but maybe this is a useful chart for you to be thinking about the question that you would be asking and the type of taxonomy for modeling. So in terms of terms, you can have semantics. These are the signs and symbols, and the syntax is the way in which the signs and symbols are put together. Sysml needs to have a semantics and syntax defined. IDEF0 does as well as any other type of modeling language you might be using. So the requirement for Sysml modeling, the requirements and meta-system models will use, this is done with use cases and sequence diagrams, as well as the requirement relationships within the requirements diagram. So that's we have these four main pillars. So this is the requirements, and Booty likes to be thinking about meta-system as well. But mostly the requirements is what we're focusing on. The behavior modeling of the system activities are processes, including both static and dynamic, using activity and state machine diagrams. Structural modeling of the system includes block definition and internal block definition, which is derived from the class diagram in UML. But I think calling a block definition and internal block diagrams are much more descriptive for what we're trying to accomplish. And then finally, parametric models of performance are characteristics of the system with parametric diagrams and the physical quantities they have to fulfill that are connected to the requirements. So those are the four pillars. There's also process and structure of the system engineering team is taken using the package diagram. So that is another thing that flows in here as something else. And this is the way that Booty likes to have that fleshed out. When Booty talks about Sysml versus non-Sysml, I don't necessarily agree with everything, but I think that there are the block definition diagrams that can also be used in the static views. And so that is something that's there. So I'm not going to really dwell on this chart, but this is talked about in the textbook. So Booty does have a few examples of Sysml diagrams. And so here is an example of a use case. And so you can think of these various people. And so this is dealing with our elevator. And so you have passengers, you have maintenance, building personnel, certifiers, and the building management. And each of these have to be doing different functions relevant to an elevator. So this is what a use case diagram can look like. For a, this is a sequence diagram, and so you can see the relationships between the passenger and the elevator, how information and various things are passed from one to another. So that's another type of diagram that we'll be seeing. For the block definition diagram, there's a couple of semantic elements that are need to be laid out. And so you have the block, and so this is the name of the component. And then you have the types of connections. And so you can have this little diamond, and you can have a number associated with what is the possible multiplicities that might be associated with that, and the name of the subcomponent. So there's a lot more information that can be laid out in the block definition diagram. You can have a lot of parameters and things. And so different ways of showing those details in a block definition diagram can illustrate that. And so here, this is a still fairly high level. And so you have these different blocks. And you have the names of those blocks, those relationships. Here, the elevator system, and here are the various components of that elevator system. And there's other things in these little sub boxes that can be filled out, but for right now, this is still a top level, and so we're really not talking about that in detail. For a block, this is the block diagram for functional objectives, and so this is still a block definition diagram, but you can see how things can be related to one another. This is dealing with requirements, and I think that this is a requirements document. So although you can maybe see there can be a little bit of ambiguity at times between what you would be trying to do with requirements diagrams and say block definition diagrams. And so I'm just going to leave this as an example, but we're going to be getting more into this into the course. For an internal block diagram, this is the thing that I want to be focused on, is you can have this port. And so this is like gets into an interface of where and how information flows from one element to another. So here we see these different connections that you're defining an interface, and you can get into the detailed quantification between these different interfaces. And this is once again talking about the elevator system. And I think that's it, because the rest of these chapter is dealing with IDF0, and I'm not going to be focusing on this. So I'm just going to quickly go through these charts. You're welcome to go through this as much detail as you would like. It's definitely in the textbook, and it's also in these charts. So I'll just go through these one at a time. And feel free to look over those. Functional flow block diagrams. This is similar to the block definition diagrams, but we're not going to talk about that here in detail. And so that's going to be it for this lecture. Thank you very much.